Good morning. It's 10 o'clock Central Standard Time, February the 2nd, 2021, here at the Dallas Schools Environmental Education Center. We want to welcome Indian Creek Southwest ISD, Edward Teich, Dallas ISD, to our program this morning. Hope you enjoy. Most of all, though, we hope that you learn something. If you're watching and you have not signed up, please go to www.tiny.cc/EEC register and sign up. This is just for our attendance records only. This morning, during this virtual field trip, students will discover that the natural world includes air around us and objects in the sky. Students will observe weather conditions, including relative temperature, such as hot or cold, clear or cloudy, calm or windy, and rainy or icy. Mr. Ramirez will tell you about the importance of recording weather. Ms. Nash will discuss the different winds and clouds. Mr. Monroe will tell you all about weather tools. Ms. Fuller will discuss weather stations and how to construct one. And we'll have a guest meteorologist, Mr. Wesley. During this field trip, you will not be able to talk directly with us, but you can ask us questions by going to www.tiny.cc/EEC /question/answer. We'll be glad to try to answer all of your questions. And now I'm going to stop sharing my screen. And Ms. Ramirez is going to tell you all about recording weather.
Hello, my name is Ms. Ramirez, and in this segment, we're going to observe and record weather here at the Environmental Center. So I'm going to go ahead and share my screen with you guys, and we'll start our presentation. It might take just a second to get the screen share going. So in our first little slide, since y'all aren't able to visit us here at the Environmental Center, I took some video clips of weather over the span of the last 2 weeks here at the center. So I would like for you guys to observe and describe what you're seeing in the video. So think about what senses can you use to observe weather. So we can use our scientist eyes to help us observe weather. We can use our scientist ears to help us listen, for example, to the rain or the wind. And we can use our sense of touch to help us feel the temperature outside. Now, since y'all can't actually feel the temperature with us here today, see if you can make a prediction on what the weather would feel like. So I'm gonna share my video with you guys. We'll see if it will play this time around. I'll put it in full screen. Again, make some observations. And this is the pond that's behind our facility. This is the hidden lake that's across the street. Now that one's not from the Environmental Center. That one is from Abbott, Texas, back in January when some parts of Texas got snow. There's our windmill. So think about what the windmill can tell us about weather. Hopefully you notice that super loud, windy sound. And our windsock. So what does that tell us about the weather? And this was a gorgeous sunny day. And you can see a couple of our cattle enjoying that beautiful day. I'm going to stop our video and hopefully you guys were able to make some quick weather observations. So what I did was I recorded the weather and I created a key and I decided I was going to record 4 things about weather. So I was going to record the temperature, whether it was cool, cold, warm, or hot. I was going to record cloud coverage. So was it a clear blue sky? Was it sunny or was it cloudy? Now it's important to note that some clouds can be pretty and white on a nice day, and then some clouds can be dark and gray, which might signal rain. I also decided to record precipitation. That just means, is it raining? Is it snowing? Is it hail or sleet outside? And then also to record wind. So was it a calm day, a breezy day, or a very windy day? Now we can use data about weather, and that data can be recorded and organized using pictures and words and numbers. And also we can make predictions about weather based upon our recording. So for example, here's a prediction of a weather forecast for next month, March. So using data from previous years, scientists can actually make predictions about what the future weather might be like. So it's predicted for next month during our spring break, which is circled right here, that we might have temperatures in the upper 60s or lower 70s. So we should have a pretty good spring break next month. So now let's take a look at some weather pictures here at the Environmental Center. So these were taken Monday, January 25th in the morning. So make some quick weather observations based on these pictures. So think about, can you name some of the weather tools? Also think about, what do these weather tools tell us? And think about, if you were to record weather data for this day, what would you write down or draw? Now I'm going to go through these pictures rather fast, so if you need to, feel free to pause the video stream to allow yourself more time to make observations. But in our first picture over here, we actually have hail. So I got hail the morning of January 25th. And that's an example of what it looked like. So it was a really bad thunderstorm, really dark, lots of lightning and thunder, and these big pieces of hail came down. Also, look at our windmill over here. It's dark and cloudy skies. And look at our rain gauge. The rain gauge can tell us the amount of precipitation, in this case, rain, that we received. So we have our hail, our rain gauge, and our cloudy day. Now let's take a look at how I recorded this information. 1 second. So let's take a look at later on that afternoon. This is that same day, but in the afternoon. Notice the difference. So now we have a clear sky with a few white clouds, and those white clouds are kind of thin and wispy. They remind me of like a mustache. Those are called cirrus clouds. We also have our thermometer here that tells us the temperature, and we can see that it's about 70 degrees, so it was rather warm that day. Notice the difference between the morning and the afternoon. It was super different. We went from rainy day to nice, beautiful day. So that's why it's important for us to record the weather. And here's an example of how I recorded that weather. I did a recording for the morning and then one for the afternoon because it was totally different. So weather can change not only day to day, but also within the day from hour to hour. Now here's the following day, Tuesday. Again, make some quick weather observations. What can you say about our weather on this Tuesday? Again, you can pause the video if we're gonna go too fast, but here we have our beautiful sun. So it was a sunny day. There were no clouds, so it was clear. Notice our temperature in our thermometer. It actually dropped. So the previous day it was 70 degrees. This day it was 50 degrees. So it was kind of a cool or chilly day. But look at our windsock. It wasn't moving. It was nice and straight or vertical. So what does that tell us about the wind that day? So it was actually a very calm day. And let's take a look at how we recorded this information. So here we have cool weather. It's about 50 degrees. It was sunny. We didn't have any rain, and it was a calm day because our windsock wasn't moving. Now here's Wednesday. Now make some quick weather observations. What do you guys notice about the cloud coverage? What do you notice about our windsock and our temperature? So we can tell our clouds, it was a cloudy day, but these clouds were nice and white. They looked like cotton balls. They were so white and fluffy. These are called cumulus clouds. Look at our windsock. Look how it changed position this day. This day was a super windy day. Our windsock was no longer still and straight. It was now completely vertical, and it was moving rather quickly. Our precipitation and our rain gauge, there was no rain that day, and our temperature continued to drop. So now we are in the lower 40s. So rather cold for me. And I remember this day really well. It was so cold and windy, I could feel that wind just freezing my face. So let's take a look at how I recorded this day. I said it was rather cold for me, but it was a sunny day and it was super windy. So my challenge for you guys is see if you can observe and record weather where you live. So think about, what kind of weather information do you want to record in your science journal, and how do you want to represent it? So do you want to use words? Do you want to do pictures or icons like I did, or colors? And then think about how are you going to record this in your science journal? So I'm going to stop our screen share, and that's all I have for you guys for weather observations and recordings. We're going to pass it back to Dr. Gorman, and he's going to answer any questions.
Thank you, Ms. Ramirez. And we did have a question, and Why is a weather record important? Weather record is important for recognizing local climate trends and forecasting. Now, you heard Ms. Ramirez forecast or predict that the spring break will be nice weather, fairly warm weather. We're going to hold her to that. And if it's cold and rainy, we might have a few words with her about her ability to predict the weather. And now we're going to have Miss Nash tell us about clouds and the weather.
Hello, welcome to my classroom. Today we're thinking about clouds and weather. And if we were out in outer space and we looked down on our beautiful blue planet, we would see a lot of white stuff all around. Those are the clouds that circle our planet. Can you see them? They're all around. And they're being moved around by the winds. Okay. And the wind is caused because the water of the planet heats up more slowly than the land. And the land cools off more quickly than the water. And that causes wind. And the other day I went out, since you can't come to visit, I went out to look for some clouds. I love to look at clouds. Let's see what I found. There were some beautiful ones this morning. On my way to work, they were so amazing. I wish I could have taken some pictures of them, but I was driving. Now, so you go outside and you can look at them and you can learn my poem called White Sheep. White sheep, white sheep, on a blue hill, when the wind stops, you all stand still. When the wind blows, you walk away slow. White sheep, where did you go? So those white sheep on the blue hill, what do you think they are? They're the clouds. And the wind either moves them or doesn't. These are some beautiful clouds I saw the other day. And here's the clear day with no rain. And then a few days before, we had these dark clouds here that might bring some rain. So when they've got that gray underside, that means it might rain. And here you can really see that wind like blowing those clouds around. It almost looks like a tornado, but it's not really. It's just a wind blowing those clouds around. Here they are. And then on Saturday, it was super windy at my house. I have another poem that you can learn. Who has seen the wind? Neither you nor I, but when the trees bowed down their heads, the wind is passing by. It was so windy that day. The clouds were moving super fast and the trees were going back and forth, back and forth. The birds were having a hard time flying. Well, I'm just showing my poem. Part of my point. But here's some beautiful sky in the desert. And you can see here, because in the mountains, you can see a long way. You can see the rain coming out of that dark cloud. See the rain coming down and the beautiful sunset. As the sun goes down, it lights up those clouds. Here there are more rain coming down. And this is like the sky looked this morning, okay? You can see it kind of going, all those clouds going back, down, 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 and you can see that distance, okay? And there they are again, beautiful sunset, that beautiful desert sky. Now, where do clouds come from? Well, evaporation and condensation. So if I leave this out, it'll disappear. It will go into the air. It will evaporate. Evaporation, the water turns into vapor. See that word in there, vapor, meaning in the air. And if it gets cold, it will condense. It will become a cloud. You can make your own cloud on a cold day by going outside and going, and you make a cloud. I can take a mirror and blow the hot air from inside my body onto the mirror, okay? Now, see, it's hard to see, it flicks back and forth. You can do your own cloud, and I can make a cloud right here. I have a little bottle, and I've got this weird thing on top, and I'm gonna squeeze it, and I'm gonna put more air inside. And as I pump it, it gets really hard to push. And as I push that air inside, it makes it hot, okay? Makes it hot. So that air is getting hot in there. It's all pushed together. And then when I release it, it's going to cool off. And watch what happens. I made a cloud in a bottle. Pretty amazing, pretty interesting. So clouds are really fun to observe. You can make a cloud journal. Just make yourself a little accordion paper on blue paper, and then you can draw the clouds you see every day. These are those cirrus clouds. Cirrus means hair. These are those cumulus clouds, keeping lumpy clouds. Okay? And then all the different clouds. You can also use a cotton ball and a glue stick to make some really cool cloud art. So it's a fun thing to observe and learn about. And if you have any questions, I'm going to turn it over to Dr. Gorman.
Thank you, Ms. Nash. And we did have a question, and it was, what do you call the cotton ball looking clouds that are big, white, and fluffy? And they're called cumulus clouds. And I want to share something with you right quick that happened to me many years ago. I used to fly as a search and rescue air crewman in a helicopter. And many times, if the cloud bank was real thick, we would take the helicopter and fly up above the cloud bank, and it's just completely flat on top of most of those clouds. It actually looked like you could just get out of the helicopter and walk on it. It was so white and thick, but none of us ever tried to get out and walk on it. Now we're going to let Miss Nash, I'm sorry, we're going to let Mr. Monroe tell us about weather tools.
Good morning, students. My name is Mr. Monroe, and we're going to be looking at a variety or some different tools that very special scientists called meteorologists, they use to measure different weather conditions. Now, whether you know it or not, there are three major things or components that make our weather here on planet Earth: the sun, water, and air. And believe it or not, meteorologists have tools that will measure the effects or those elements so that they can be able to predict and forecast the weather, which is very important. Now, as far as the sun is concerned, we know that the sun is the source of light and heat energy for our planet. It heats up the surface of our planet, and it also heats up the air. And there's an instrument that we use, or meteorologists use, to measure how hot or how cold the air is. Ms. Ramirez showed you the thermometer that she was using to take measurements to make her recordings with. And we know that thermometers can come in different forms. Here I have a thermometer, which is probably the most common looking thermometer that we have. It has a fluid inside of a tube that fluid, as the temperature rises or gets warmer, that fluid is going to rise and give us a reading. If the temperature starts to fall and get cooler or colder, then that fluid begins to drop and it gives us a cooler reading. A thermometer might have two sets of numbers. One set of numbers, for example, like the numbers on this side of the tube, you see the C, that stands for Celsius. So these are units of measurement that are associated with Celsius units that belong to the metric measuring system. On the other side, we have numbers that are a little bit spaced out, a little bit in different locations, and there's an F that stands for Fahrenheit. That is the customary side of this thermometer. And most of the time, we still use the customary measurement, Fahrenheit, okay? Now, a lot of the other countries like England and France, they use the metric system. Now, thermometers don't have to look like this. I believe Ms. Ramirez showed you one that was in circular shape like this, but they still do the same thing. They measure how hot or cold the air is. And that's very important for meteorologists to figure out what type of weather pattern that there is actually going on at that time and what may be coming. And I will tell you this, most of the time, just before we get a cold front, the day before we get a cold front, there is a change in the air temperature. It warms up just before that cold front comes in. Now, the other component that makes our weather is rainfall or precipitation or snowfall. And there's an instrument that meteorologists, remember they're scientists that study weather, they use that to take measurements of how much precipitation has fallen. Ms. Ramirez showed you a rain gauge that looked very similar to this. It's marked off in numbers. So if we put this out in the open and it was to rain, it would fill this gauge up, and there's a little flotation device that would raise up and it would mark where the amount of rainfall has brought it. And it would give us the amount of precipitation that is fallen. I've often wondered that when it snows, do you need a rain gauge? Well, not really. You could take simply a ruler and go out and stick that ruler down into the snow to measure how much snow we had got, because it definitely would be a little different from the actual liquid form of precipitation. Now, this is a complete, what I call a mini weather station. It has all types of apparatuses on it. It has a thermometer. It also has a rain gauge. And this rain gauge is a true rain gauge. On one side, we're using customary measurements in the form of inches. On the other side, it is Celsius, which is a metric form, centimeters. And again, it works the same way as the example I showed you. When precipitation falls, it collects into the rain gauge. Now, one important thing, if it rains one day and you take a measurement, we need to expel or get rid of the liquid that's in there. Otherwise, you're not going to get a true reading, are you? We don't let it build up. One day it rains an inch, we need to get rid of that inch and get ready for the next day that it's going to rain. Otherwise, we don't get a true reading. Now, the other component that makes weather is something that's invisible all around us, students, air. And right now, we can't see air, but we know it's there. About the only time we can see that air is if it's moving. Moving air, we call it wind, right? And it's very important that we measure the wind. Not only measure how fast it's blowing, but also what direction it's coming from. And I'll tell you this, that's very important. Most of the time, if the wind is blowing from the north, that air coming from the north is associated with the cold air that's up, or cold locations that are up north of us, and that air is going to be very cool. Other times, if the wind is blowing from the south, then that air most likely is going to be warm air. There is an instrument called a wind vane. When I was in elementary, I lived in Oklahoma, little rural town, and you could go out on the edge of town and you'd see several barns that at the top of that barn, there would be a wind vane, and that wind vane would be an apparatus that had arrows on it, and those arrows had letters, for example, E for east, N for north, W for west, and S for south. And you would see that turn around. And in the middle of that apparatus was the image of a rooster. Now, I don't know why they had a rooster there, but it was there. This is an example of a wind vane. Now, if the wind is blowing, this arrow is going to show what direction the wind is blowing from. And it'll spin around using that rudder to make sure that the wind is pushing it that way. And again, just like I said, there's letters. W for west, S for south, E for east, and N for north. And you would always make sure that when you put one of these up, you want to make sure that each of these directions are facing the true direction. For example, north in my lab right here would be that direction. So if the wind was blowing, the rudder would probably turn this that way, and that would tell us that the wind is coming from the north, okay? And then wind speed. Meteorologists use a tool called an anemometer. Sometimes it will appear like an apparatus, and this is just a model with little cups, and the wind would catch those cups and spin it around. And then it would calculate it, be hooked up to an electronic device. It will calculate how fast the wind is blowing. The other day, I believe it was Saturday, we had some very strong winds. Of course, I didn't have an anemometer, but I knew they were strong because I walked out into the alley behind my house and I could see my neighbor's trees. Guess what they were doing? They were dancing in the wind, weaving back and forth. And I knew at that time that the wind was strong. Now, an anemometer would tell us how strong those winds were, and it would also tell us how fast the winds were blowing. I believe the winds that day got up as high as somewhere between 40 to 45 miles per hour. There are other apparatuses that we use to also calculate or look at how strong the wind is blowing. Ms. Ramirez showed you her windsock. You know, the other day I wanted to go purchase a windsock so that I would have one here to show you guys as an example and make it work in front of you. I went into the store and I asked the salespeople if they had windsocks. The young man that was trying to help me, he looked at me and he said, well, what is a windsock? Is it some kind of sock that you put on your special sock you put on your feet? And I had to correct him. I said, no, it's an instrument that a meteorologist would use to determine how fast the wind is blowing and what directions it's coming from. Well, we've got a very creative teacher here on our staff. When I told her I couldn't find a windsock, guess what she did? She made a homemade windsock for me. Now, we're going to see if this thing really works, okay? Now, I'm going to take and provide a little bit of wind using this blower. And we're going to see if it really works, okay? Y'all ready? Here we go. Yep, that's how a windsock works. If the wind is blowing strong, it's almost straight out, isn't it? Now, if I cut it down, look what happens. It lays to rest. That's how a windsock works. And you might say, where do they use a windsock at? Well, smaller airports, for example, around my hometown, there's a real small airport and they do have a windsock because it's very important that those smaller type airplanes that are coming, landing on that little airstrip or taking off, they need to know how strong the wind is and what direction it's coming from. Of course, there's other instruments too, like a barometer. Very similar looking, looks like this clock, but it has a different purpose. It is used to measure air pressure. In other words, how heavy the air is, because warm air is lighter than cold air. Also, there are satellites that are orbiting around our planet that's taking pictures of clouds and different weather formations that are on the surface of our planet or close to the surface of our planet, that's providing different weather conditions for our planet. And they can also use those pictures, for example, a picture of a hurricane, trying to determine where they're headed and what's going to be going on in the near future so that they can predict and forecast the weather. Also, a very important tool that meteorologists use is a weather map. They can chart different weather conditions in different areas, and they can give an idea of what's going to be happening in the next few days. Most people don't realize that because the United States is in the northern hemisphere, most weather patterns will move from the west to the east. So the pattern is already set, guys. Hopefully I've been able to help you kind of understand about the use of some of these instruments as far as meteorologists, giving them the ability to predict and forecast the weather, which is very important for us in our everyday lives. If you have any questions, I'm going to turn it back over to Dr. Gorman, and maybe he can answer those questions for you. You guys have a good day today, okay? All right, Dr. Gorman.
Mr. Monroe, the question came in. What is the most common weather instrument or weather tool? I think most of you can probably figure that out right now, and it's going to be the thermometer. That is the one that everybody is interested in. Now, other people are interested in the wind speed and how much rain and all, but everybody wants to know how cold it is or how cold it's going to be. Now, I do have a little research question for you guys. In the morning, when you get to school, hopefully your teacher's going to ask you, how cold is it on the thermometer on the Fahrenheit and on the Celsius side when water freezes or when the temperature freezes? How cold is it on the Celsius side and on the Fahrenheit side on the thermometer? You can just do a little research. You can look that up. All right, now Ms. Fuller is going to tell you about weather stations.
Good morning. It's good to see you, or for you to see me. We're going to talk about homemade weather stations. And you may say, Ms. Fuller, I'm in the first grade. I can't make a weather station. But actually you can. We're going to look at the big people weather station, the fancy ones, and then we will see how we can make one ourselves. So let's see how to make your own weather station. Now, it's fun to observe and record the weather. Remember, when we observe the weather, we have to write it down. We have to record it. So let's look at these three very official looking weather stations. One is a buoy, that's that bright yellow one out in the ocean, and it's got all kinds of weather instruments on it to measure weather. In the center, we have a satellite, a weather satellite, way up in the air, way up in space, and it collects weather information from all over the world, can tell us all about hurricanes, where they're forming, where they're going. And then on the right, we've got what looks like a giant golf ball sitting on top of a building. That's a Doppler radar. And Doppler radar can track storms and tell you exactly what's in the storm and where it's headed. So let's look at the things we want in our weather station. We want a thermometer. Both Mr. Monroe and Dr. Gorman have told you that that's sort of the basic instrument for measuring weather. It measures temperature. And if you look at this one, on the side that you're looking at on the left, it says degrees C, that's degrees Celsius. That's the metric system. It's all in tens. And on the other side, degrees Fahrenheit. That's part of the imperial or standard measurement system, customary. That's what we use here in the United States. Everybody else in the world uses metric. All right, here's a wind vane. This one happens to have a chicken on top like Mr. Monroe was telling you about. And all it does is measure or indicate wind direction. And we name the wind the direction it comes from. This is a rain gauge. The rain falls in, you measure it and make sure that you empty it after you record your measurement so that you don't accumulate rain from one day to the next. And this is a windsock or wind speed indicator. The one on the left is what you would see at an airport. The one on the right, those are just simply flags, but they're flying straight out because they're having a really, really stiff wind that day. So let's look at how we can make our own little instruments. Okay. Well, I said make, but you actually have to buy a thermometer. But you have to ask your parents to buy you a little thermometer. This kind is very inexpensive. The key thing is you have to put it in the shade. It can't have the sunlight on it anytime. You can put it on the side of a shed, on your patio, on the side of the garage, but it can't be exposed to sunlight. It has to be in the shade. You want it to measure the air temperature, not the temperature of the sun. The next one is, oh, here's a rain gauge I made. This is really fun. You'll like this. You just take an empty soda water, 2-liter soda water bottle, and I put plaster of Paris in the bottom for 2 reasons. One, it makes it heavy so it won't tip over or fly away, blow away. And the other reason is it makes it real flat on the inside. So we have a nice flat surface so we can be accurate when we measure our rain. You keep the top, you put it in here like that to act as a funnel. Now, I put some duct tape on the side, and then I took a ruler and I measured in inches on this side imperial measurement. Then when you listen to the weather on the TV, they'll say, well, we got 1 inch of rain or we got 1.5 inches of rain. That's this one right here, United States of America. This is metric system, rest of the world. And this is in centimeters, and it just marked up there. So remember, the metric system is very easy because it's all in multiples of 10. All right, now the next one we have, oh, look at this. You may not be able to sew a windsock, but you can cut one of those little grocery bags you have 10,000 of and make it in strips. And then all you have to do is tape it to the end of a little stick. And then when it got a little bit of rain, a little bit of wind, move a little bit. And when there's a lot of wind, it goes out this way. So you could just record a low wind, medium wind, or high wind. All right, and the last one we're going to look at is a weather vane. Now, all I did, this is very simple to make. I took a blob of Play-Doh and put it on this clipboard and stuck a pencil in the middle. It has to be a pencil with a real good eraser. See, this one's got a good eraser. And then I put a little round thing. It's actually the size of a CD, and cut out the middle. And then I wrote north, south, east, and west on here. And then I'm going to put it right there. Then I took a drinking straw, shoved a pin through it, and put the pin in the eraser. And I put a slit at the end of each end of the drinking straw. This is the tail, and this is the point of the arrow. Now this pointed end has less resistance than the feather end. So the weather vane will always point in the direction that the wind is coming from. That's how we name the wind, where the wind is coming from. So here's a little compass. I'm going to put it right here. It's going to say north is that way. So I'm going to fix my little device here with north, south, east, and west this way and take it outside. And if the wind is coming from the north, it's going to look like this. If it's coming from the south, it'll blow this way, because remember, the pointy end has less resistance than the feather end. So it's going to point to the direction that the wind's coming from. All right, my time is up. If you have any questions, ask Dr. Gorman. He'll be glad to answer them. Thank you.
Thank you, Ms. Fuller. And the question is, why do we need a weather station? Well, we could get along without one if we had about 10 instruments to carry around in a box or something. Or you can have a weather station. And Mr. Monroe showed you a very good, I think he called it a mini weather station. It was a device that did about 4 or 5 or maybe even 6 different things with the weather. It told you the temperature, it told you how much rain, told you the direction it was coming from, told you how fast the wind was blowing. So it's just convenient. He had everything in one little package. Or you could do like Miss Fuller did. You could take a couple of 2-liter bottles and some pencils and all and make your own weather station. Now, thank you, and Mr. Fuller, and we're going to go to Mr. Broughton, and he's going to introduce Mr. Wesley.
Thank you, Dr. Gorman. I'm going to share my screen here. So we have learned a lot today about weather and how to measure weather and record weather. And if you're wondering, well, what can I do now that I know how to do that? You could grow up and become a meteorologist. And so we're going to meet a meteorologist in here in just a minute. But I'm going to tell you just a little bit about him first. His name is Mr. Wesley, and he works for the Texas Commission on Environmental Quality. And you can see here right at the top, they spend a lot of time studying the air, land, and water, and making sure that we have good quality air, land, and water here in Texas. And another part of that commission is this website here. It's takecareoftexas.org. They teach people how to conserve water, keep water clean, keep our air clean, reduce waste. They have a lot of resources for kids and teachers that are free to request. And they're a really great resource for how to take care of Texas. And his job as a meteorologist, and I'll let him tell you what he does here, but you'll see how that being a weather person connects to taking care of Texas. So here is Mr. Wesley.
Hi, my name is Wesley, and I'm a meteorologist with the Texas Commission on Environmental Quality, but we call it the TCEQ for short. The TCEQ is a state agency that protects our environment and makes sure our air, water, and land is protected from pollutants. We also teach Texans about how they can help keep Texas's environment clean. I'm a meteorologist, but you might have heard the job called a weatherman. A meteorologist is a scientist who studies the weather and makes a forecast so we know what the weather will be in the future, which could be the weather tomorrow or the weather in a month. I'm a little different than the weatherman you see on TV. I track weather to study how it will affect our environment, as well as track how it affects air pollution. Sometimes pollutants can make our air dirty, which is especially important to know if you have asthma or other health problems. I make sure Texans know when the air is safe and clean to play outside. We use a colored chart to show how clean the air is. Green is the best and purple is the worst. Typically, we see orange ozone action days in the summertime when there's lots of sunshine and winds are light. They're also more common in big cities where there are more cars. To study the weather, I use weather measurements. Those are taken by air monitoring instruments and by air investigators. They work all across Texas, taking data with handheld monitors, air monitoring vehicles, and stationary air monitors. Their machines can sense lots of different things about the air that we can't see with just our eyes. They can tell us the temperature, pressure, humidity, and different types of invisible particles that are floating in our air. I use the information they gather to decide what that means for the weather and predict the amount of pollution that might be in the air. You can even monitor the weather yourself by using thermometers, rain gauges, anemometers, wind vanes, barometers, and hygrometers. Texas weather is very unique and special. Texas is very large, which means we have different types of weather across the state, even in a single day. It could be snowing in Amarillo while people in Corpus Christi are playing at the beach. In Texas, we have beaches and mountains, plains and hills, swamps and deserts, forests, and, well, you get the picture. Because of these different types of land, we see lots of different types of weather. Some of the types of weather we see in Texas are thunderstorms, hurricanes, tornadoes, snow, and fog. Texas has several different types of weather patterns that we see year after year in our state. Some common weather patterns we see are cold fronts, which are large areas of cold air that move across the state. Cold fronts cause some of the most interesting weather events that happen in Texas. When a cold front comes through, it's pushing the warm ocean air back out over the Gulf of Mexico and brings in the cold mountain air from the north. It happens all across the state as the cold front moves. This is why you might wear shorts one day, but the next day you might need a jacket. Another interesting weather event we see in Texas is hurricanes. They are very interesting to watch because we, as meteorologists, try to figure out where they are going to go. This is important so we can know whether or not it will cause problems for people who live close to the coast of Texas. It is important to know the difference between weather and climate. Weather is what is happening today and the next several days. Climate is the average weather over a longer period of time, like months and years. For example, even if the weather is rainy today, if it is the only time it has rained in the last 6 months, the overall climate during this time period would be dry. At the TCEQ, we track both weather and climate, since they are both very important. Thanks for taking the time to learn more about how the TCEQ helps you take care of Texas.
All right, so I'd like to thank again the Texas Commission on Environmental Quality for working with us, and a special thanks to Mr. Wesley for sharing what he does. If you are interested in weather, you can definitely consider becoming a meteorologist when you grow up. Now I'm going to turn things back over to Dr. Gorman, who's going to answer any questions you have.
Okay, thank you, Mr. Broughton and Mr. Wesley. We appreciated that. And a question that came in was, what do I have to do to be a meteorologist? You'll have to go to about 3 years of a specialized school that deals strictly with teaching, predicting meteorology and the weather. All right, now I'm going to share my screen. And during this virtual field trip, students discovered that the natural world includes air around us and objects in the sky. Students observed weather conditions, including relative temperatures such as hot or cold, clear or cloudy, calm or windy, and rainy or icy. Mr. Maris told you about the importance of recording the weather. Ms. Nash explained the wind. Mr. Monroe showed you many good weather tools. Ms. Fuller showed you how to make a weather station. We had a guest meteorologist. Thank you for watching. We hope you enjoyed it. We hope you learned something. And teachers, if you would, fill out the how did we do part of it. www.tiny.cc/EEC feedback and tell us what you thought of it. And we do appreciate your feedback because that helps us to make sure that we're on the right track for helping you teachers in the classroom. You guys have a great day, but most importantly, you have a great life. Thank you very much.